All right, there we go. Hopefully I can still get answers from you guys like live. But just a reminder, you do have Desmos testing. So once again, we're gonna have a Kiosmo. So I don't think you need to go over to the website and click on the test mode by New York State. But once you open, it will already look like this. And okay, we're gonna start. I'm gonna probably zoom out a little bit and give this a bigger screen. Today we're gonna go over the 2025 January regions because like there's three regions, January, June, and then August every year. So yeah. We're going to take a look at starting from the beginning all the way to the end. I'm going to try to use the information that we have learned already. If not, we're still going to go ahead and see that, okay, maybe next week, the week after, we're going to learn some content that we haven't talked about yet, especially about the quadratic, or also the sequence, all of those things. So the first one says when factored, the expression of x to the third power minus 36x is equivalent to any of those. Once again, regions, we have decimals. That's going to be our last resort always. So I was thinking if you decided not to actually solve it by hand, then you will have the option of using decimals graphing calculator as an option. But once again, I'll show you both. But right now I'm going to go ahead and try to do the handwritten version, which is like without a calculator, how would you do it? We do have seen this before back in a long time ago. Uh, Probably September, November time. Very early beginning talking about factoring, which is undoing a distribution. Or you got a couple methods. You can actually solve this and do a factor, or you can grab all of these four answers and do a FOILed, which is a lot of work. So let's see whatever that you're most convenient of. So look at this, x to the third power, and then minus 36x. And then as we know that we both see a letter x on both sides, so I'm gonna go ahead and take a look at the x. So after you take out the x, you're gonna have an x squared in the front because x to the first power plus x to the second power together will be a third power. So that's what happened for the multiplication. All right, and then on the other one, we're gonna have, let me move this a little bit over. There we go. Okay, and that minus is still there. 36x separated with the letter x, you have a 36. So that's how your first time separating. After that, x squared minus 36, you notice that x squared is a square. 36 is also another square. So you can think about the differences of square. Differences of square is a formula. So a squared minus b squared will turn into a plus b times a minus b. So you know that in here, that will turn into x plus 6, and then another x minus 6. This is how you normally do it if you actually do understand what is difference of square and how to do factoring. So you'll have this as your answer. But if you're not happy with this, we can actually go ahead and go from the foiling method, coming from all your solutions and bring to the question. And that's the thing that I like about regions is you have a multiple choice. That means you will be possible to see starting from the answer to the question as a reverse answer. Hi there, Maddie. Hi, Maddie. All right. So how do we get from a solution point of view to a questions point of view? Let's take a look. If the first one, if I FOIL it, let's see how a FOIL is gonna do. Oh, x and x, so I got x squared. X minus 6, I got negative 6x. X plus, positive 6 and then times x, you have positive 6x. 6 and 6, you have negative 36. Well, combined like terms point of view, we know that positive 6x and negative 6x gonna cancel out each other. So that will turn into x squared minus 36. But I know that this is not x cubed minus 36x, so number one will be gone. From other point of view, once again, we can do a FOIL, same exact thing over and over again. This will turn into an x squared minus 18 squared. But once again, not our answer. The last one, when we FOIL again, x cubed minus 18 squared and then x. We don't have an answer. The only thing we'll have is just answer choice number 3. So that's the reason in there. But once again, as we mentioned yesterday in Desmos graphing calculator, what would happen? Let's take a look. If I type in x to the third power and then minus 36x, I have a picture looking like this. I gotta zoom out. So I will have a wavy line looking like this. That's 3 waves. So whatever it is, exponent is going to be talking about how many waves that we have. We talked about this before. Let's see, probably -10 and +10, and then y-axis there. So this is a better point of view. You see a really, really weird wavy line right there. So let's go ahead and take a look at all of the answers. As we mentioned before, you punch everything in, then you can see if that is going to be our answer. X plus 6 and x minus 6, they'll show up below. Just by looking, we know that they look totally different, so that's not our answer. We could type another one, x plus 18, then x minus 18. Look at that. That is going to be zooming out a little bit. We have a green one. Once again, totally different. So that's why we know that's not going to be our answer. So that's how number 1, number 2 is not our answer. Number 3, having an extra letter X in front of it. Let me type it in. Look at this. The green one is totally different. Once again, answer number 4 is not an answer. Now, if I delete that, let's just focus on answer choice number 3. So X, and then X plus 6, and then x minus 6. Look at that. Purple and the red are perfectly overlapping. How do I see they're perfectly overlapping? I can click the purple, hide the purple, and show the purple, hide it, show it, hide it, show it. Once again, they're perfectly overlapping. That is how you know the answer choice number 3 is going to be an answer. So far, okay on number 1. Okay. No question asked. Nobody say anything. So I guess y'all are all good on this question. All right, number 2. Which equation represents the line that passes through the point of these two? If we're solving it by hand, definitely going to be using our slope formula, which is y2 minus y1 divided by x2 minus x1 if we're doing it by hand. This is going to be asking you for the slope. What is going to be our slope? We have done this before a lot of the time for the practice, and we plug it in. I have a -2 minus a 8. Then I'm going to divide by 4 and minus a -1. I keep putting in parentheses just, God forbid, in case I accidentally mess up with any of the negative signs. So by doing it in a calculation, I have a -10 divided by a +5 equals -2. So that means my answer choice is definitely between 1 and 2. And then what? I'm going to go ahead and plug it in, right? Is this going to be work for number 1 or number 2? So I plug it in. If I have a -2 times -1, and then I'm going to plus some number, which is the letter B, will equal to an 8. So I have a 2 plus something equals 8. So that means my B have to be equal to 6, which is right here. So that's how my answer choice is number 1. But once again, if you want to use Desmos graphing calculator, let's take a look at what happened. Now they will allow you to put tables, which is 2 points, whatever it is that they give you. We have it in here, which is -1. And then 4, and then the y coordinately is 8 and -2. So these are the 2 spots that literally show up right here. Okay, I'm going to show it here. Okay, and then what will happen? I'm going to go ahead and type in my equation. Let's see which one overlap. Let's go ahead and type in the first one. It says -2x plus 6. What happened? They perfectly crossing the 2 blue spots right there. So that is how you double check your answer. Did we choose the correct answer? Or you can just use it directly as a method of solving. You don't necessarily need to use this, but you can use this Desmos graphing calculator to double check your answer. All right. So this is how it goes. Hide it, show it to double check, then make sure that these points got crossed. All right. So once again, I always say that Desmos is always there just as a tool for you. But once again, how would you use it? Do you want to use it as a method of solving, or do you want to use it as a method of checking your answer? Just like today's in school, our step 5 is always going to be checking. So checking is very important. But once again, if you want to solve it by hand, just like I do, use the slope formula. And at the very end, slope formula is given in your reference sheet, which is right, nope, at the very end. I don't think you'll be able to rip it out based on the booklet, but there. So your slope formula is right here. We just literally see this just now. Our slope-intercept formula is also right here. We see this, but once again, it's the very end of the booklet. You will be provided with this. Okay? All right. Let's bring it back to the question. All right, number 3. This is a sequence, and we haven't actually learned it yet. That will be a data when we talk about geometric or arithmetic sequence. So just to introduce, what are they? So geometric sequence is talking about that if something is multiplying or dividing over and over again. So I would times the same ratio over and over again with the same exact number that don't change. And then arithmetic sequence is going to be I'm adding some difference, adding some number over and over again. So this letter that they use, arithmetic sequence will use the letter D, and geometric sequence you use the letter R to represent a ratio and a difference. So let's take a look at what happened in here. They said that I give you a geometric sequence that they already know that it's a geometric, so that means I'm going to keep multiplying some numbers. How did 1/2 get to 2? How did 2 get to 8? How did 8 get to 32? By keep multiplying. So you can type in the chat or unmute yourself just by analyzing. I'm not going to tell you this answer. You can put in chat or unmute yourself. What number did you multiply to get to the next number? What do you think? 4. Okay, I see it in the chat. That is correct. 1/2 times 4 is going to be 2. 2 times 4 is an 8. 8 times 4 is a 32. So that checks out. So that means we're just choosing the answer number 4. And that's how we choose this question. That's correct. Thank you, Maddie. All right, next one. What is the constant term of the polynomial da 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 da? We have seen this back all the way in September when we talk about polynomial definition. So this one, I'm waiting for your answer, either in chat or unmute yourself. What is the constant term? 5. Yay. Thank you, Maddie. Just the number 5. That is correct. So I circle 5 and call it a day. Ta-da. All right, so let's analyze this polynomial. We know that we have a polynomial in here, but we don't actually have it in the standard form. What is the standard form? We rank everything from the highest exponent to the lowest exponent, and then which is AKA our constant. So we realize that, oh, the highest exponent is a 3, so I should write it as 2x to the third power. And then after that is the second power, so I plus 4x squared, and then a minus x, and then plus a 5. This is how we go from highest exponent to the lowest exponent by 3, 2, 1, and nothing. After that, what is going to be the leading coefficient, or so-called the leading exponent? Leading coefficient is going to be a 2. Leading exponent, also called the degree, is going to be a 3. And then constant term is always going to be tested as the final free number that without a letter. So just like that. Okay, so number 5 is going to be chosen in here. And once again, in regions, they'll ask you all different things, either ask you for a degree or a leading coefficient or a constant. So this is called a leading coefficient. And that has got a degree or a leading exponent. They're actually the same thing, which is the first term's exponent. And then 5 is going to be our constant. That is always being tested in every single year, every single region. Good. Now we finish our first page. Ta-da. Okay, so every single file that happened in all of these meetings will be exported as a PDF, and also our meeting will be exported as a YouTube video, so you guys can keep watching it and rewatch it before the test. Okay, next one, number 5. A landscaping company charges a set fee for a spring cleanup plus an hourly labor rate. So this is a very classic linear equation setup. Always going to be, oh, if that person show up at your door, you're already being charged for a fee. And then the more that they work, the more that you're going to pay them. So this will be our very classic linear equation that will show up every single year. Sometimes a plumber show up. Sometimes a kid in your neighborhood come to mow your lawn. Sometimes a person that come over to do a kid show, like a birthday party and whatever, as long as I come to your door, I'm going to charge you for a fee. And then the longer that I stay, the more that I'm going to charge you. And then this one, same thing, spring cleaning. As long as you show up at your door, they're going to charge you for the money. And then the more that they stay, the more hour rate they're going to charge you. So just by looking at this and fitting on this situation, every single time when we see these, the constant is always going to be the money that they show up at your door. Always, always, always. Whatever that's connected with the letter X, That is, the more that they stay, the more they're going to charge you. So this is always the hourly rate. All right, so that's the hourly rate. Okay, so in here, they said, oh, I give you the whole scenario. All of these words actually means nothing. But they said, oh, what does the 55 represent? They just want to know, what does the slope mean? Just that easy. This is another 8th grade standard that we have seen in our state test explaining what is the slope. Take a guess based on here. 1, 2, 3, 4. What should be your answer? Type in the chat or unmute yourself, regardless. I see that you're doubting yourself, Lily. What should be an answer? What do you think? Margaret, you can type in the chat too. Maddie, you can type in the chat too. What do you think is going to be? Hourly rate. So what is that going to be? Like literally we circled the 55 and said that's the hourly rate. So answer choice number 2. All right, the number of hours, that is going to be the letter X itself. So the number of hours of labor required to one cleanup, this is the letter X. So it's talking about the X amount of hours. As the X amount of hours. And then the profit that have nothing that actually talking about here, we never know what's the profit. And then the hourly labor rate. So that's the money for every single hour. And actually that is the 55. And then the set fee for the cleanup is whatever it is show up for your door, that is going to be the 80 hour. So in here, hourly rate, just like we circle in here at the very beginning, always. It will be changing to a plumber show up at your door. Whatever money they charge you for showing up, that will be the constant. And then whatever they charge you for every single hour that they stay at your house, that's going to be the slope. Always, 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 because that's called dollar per hour. So that's why we call it slope is something per something, right? So that's the dollar per hour. The amount of money they charge you per hour. So that's your slope. Slope, once again, keyword is your per. So that's the most important thing. Hourly rate is your per, like your constant of proportionality, that's your slope, that's your average rate of change, all of that is the same thing, which is the slope. In the future, you will also see that the mowing the lawn, a kid showing up at your door, charge you something, that's your constant. And then the more hour that you hire that guy to mow the lawn, that's going to be your hourly rate. That's going to be your slope. In this scenario, always show up every single time is either going to be mowing a lawn, the plumber coming to your house, a party show, a landscaping, all of that. Every single time a person show up, constant. And then every single time that person stay for longer and longer and longer, that's hourly rate. Okay. All right, next one, question number 6. You have seen this back in when we're doing the addition and subtraction for polynomial. This is literally just combine like terms, nothing too crazy, but we gotta be careful with the sign right down the middle. So with that, we're just taking a subtraction between the left parentheses and the right parentheses. And once again, it's just combine like terms. So if you have a pen and paper, go ahead and solve it. If you're good at mental math, go ahead and do that. Tell me what answer you're choosing, all right? After you combine the second line term, you should have the answer. Lily says 2. Anybody else? Nobody else answered? I'll take Lily's answer. Number 2 is correct. So we're going to do combine like terms. So I stare at, oh, the first one is the second power. Then the second power is right here. So 5 minus 3 is going to be 2. So I have a 2x squared. After that, I have a negative 2x and minus a positive 3x. Negative 2 minus 3 together is a negative 5x. As long as you see this, you should have an answer, which is right here. But for practice purpose, let's do the last one. We have a positive 4 minus a negative 1. Minus negative together will be a positive. So that's why 4 plus 1, which is a 5. So that's how you have your answer number 2. All right. Now, if not, then make sure that we're going online and searching up adding or subtracting polynomials to practice this expression, okay? Next one, systems of inequalities. This is gonna be one of our scheduled days. I think it's next week, Thursday, and that's what I recall. It should be next week, Thursday, talking about systems of inequalities. Let me pause right here. If it's a open-ended question for systems of inequalities, you do have a Decimal's graphing calculator. Literally, you just type it up there and then you copy paste. Do not panic. Everything's fine. Nothing's too crazy. We just graph the line and then we analyze it. Do we shade above or shade below? But let's take a look at this. So this is a key identifying for what's the feature of a systems of inequality. So this is not testing about like, do you know how to graph? Do you know how to do anything? You are just taking what's the features. Oh, I saw Chris just join. Welcome, Chris. Okay, we have our features. So features of systems, STMs of inequalities. All right, so what are the systems of inequalities? We're gonna have two lines, two straight lines will be graphed in here. And then each line will have one shade. So for this right here, they shaded above. For this line right here, they shaded below. But the only place that where they actually do have an answer is when they double shade it. So please keep it in mind that was an actual real area of answer is going to be where places are double shaded. Let me change the color to write it down. Places where double shaded is your answer. Now, there's another key point to think about is any dash line is not an answer. Dash line do not count as an answer. Dash is not an answer. So that means anything happen on this dash line will not count as an answer. Anything that one's shaded once will not be an answer. Shaded once will not be an answer. Shaded 0 times will also not be an answer. Only place that was being double shaded is right here. So this is called a solution area. All right. So this is something that we're going to learn next Thursday, but I'm going to giving you about the key features about what's going on. So next week when you're there, we're ready. So when places are double shaded, those are the only places that's called solution area. Normally we just put a gigantic letter S right down the center just to tell people that we know that that's the solution. But once again, if the point landed on the dash place, they're not an answer. So let's take a look. The question just asked for very simple stuff talking about what's a solution. So we're going to go ahead and analyze what is a solution, really, literally. So this at 1, 1. 1, 1 is right here. But 1, 1 is actually on a dash line, so that will not be an answer. The next one, 2, comma, negative 2. 2, comma, negative 2. Once again, I am on a shaded area, but I'm on a dash line. So no. Once again, the reason for rejection is dash. This is on a dash, so both of them will be no. Next one, 1, 8. 1, 8 is all the way somewhere right 1, 2, 3, 4, right here. All right, I got shaded once only, so not an answer. This is the reason is shade once. All right, so only double shaded area is an answer, so that's why here, no. Next one, 4, comma 2. This is a very classic yes, it got double shaded. It was not landed on any dash line, so this will be a good answer. So far, so good. On finding answer. Okay, thank you, Chris. Thank you, Margaret, for nodding. Okay, number 8. An arithmetic sequence. Let's bring it back. We have just explained arithmetic sequence and geometric sequence. Arithmetic sequence means that you are adding something, adding some kind of number. So adding a number or subtracting a number over and over and over again. So they said the first term is 25 and the third term is 15. What is the 10th term in a sequence? Oh, we're going to go ahead and find a difference. The first term is 25. I don't know what's the second term. I know the third term is 15. I got to find some gap. Keep going on and on and on until I find my 10th place. All right, so that means in here, on your exam, you can actually use the free space between the lines. I'm going to write a small in here. So how did a 25 become a 15 by doing the same action twice? So that means 25 got to do something become my next number, and my next number go to do the same exact thing to become 15. That should be a very easy answer. So what is happening in here? What is called the common difference? So what did 25 do to become the middle number? And what did the middle number do to become a 15?
Oh, I really don't know. Can you explain? Cause I wasn't really here for whatever you was talking about.
This question, we haven't learned it yet. We're learning it probably 2 days before the Regents. Yeah, take a guess. So how did 25 become some number and some number become 15 with the same exact action?
I think by subtracting itself, I don't know.
Yes, subtract some number, but what number? That is correct
Uh,
though. Subtract and subtract. It's the same number
mm,
that is subtract so that they become 15.
20.
uh,
It does not end with a zero. Close though.
I don't know.
Take a guess. It's just pretty numbers.
Uh,
All right, let's take a look. What's
I
the difference between 25 and 15 then?
mm, hold on, my phone's about to die.
Charge your phone. What is the difference between 25 and 15? Lily, what about you? Margaret, what about you? Okay, 25 is bigger. That is true. But how did 25 become 15? What happened in there? How did 25 become 15? 10 addition. Okay, we just mentioned 25 is bigger. So you go from 25 to 15. So is it addition or subtraction?
Subtraction.
Subtraction. So if I total subtracted 10, so that means that's two step already. I got two jump to become 15. So what's that one jump?
Y'all gotta do.
Two jump take me negative 10. So one jump is how much? Think about this. If I take two steps, I am 10 smaller. So one step, I'm how much smaller?
Uh, like 5? I don't know.
There we go. That is correct. So
5.
that means in here, that's a -5. And the
Okay.
other one is another -5. I told you the action is the same. I have to keep minus or addition a same number over and over and over again.
Oh, I didn't. So
So
it could
now,
be two numbers.
yep. So that means what's the middle number right there? What's 25 minus 5?
25 minus 5 is 20.
20. There we go. So Maddie gave me the number 20. That is correct. The middle number is 20. But the thing is, the middle gap, what was happening? It was a -5. So if every single number -5, then what is the 10th number? That should be fairly simple, right?
Uh,
So let's
oh,
go.
oh,
25,
you want me to tell you?
and then 20, and then 15.
20, 15, 10,
Mm-hmm.
5, and
Mm-hmm.
then 0.
Mm-hmm. And then keep going. This is only 6 number. I need a 10th. Keep going.
Oh, the 10th? -5,
Mm-hmm.
-10,
Mm-hmm.
-15,
Mm-hmm.
-20,
Mm-hmm.
-25.
Okay, let's see. This is my first number. This is my second number, third number, fourth number, fifth number, 6, 7, 8, 9, and 10. And then 11. But which one is the 10th?
20,
There we go.
-20.
There we go. So that's how we have the answer choice number 1, -20. Now, this is the long way, the long path of doing this. But once again, we're going to learn this in a sequence on one of the days in the future.
Mm-hmm.
Someone's screaming.
I
All right.
know my sister.
Oh. All right. And then we're going to go ahead and use this as a formula. So what is happening is at the very end in the reference sheet, you do have a arithmetic sequence. So after we actually do find the difference, oh, just now we find a difference, which is a 5, and then we can plug it in into the formula. What's the first number? They give you 25. And that AN means that, oh, let me find whatever if the number. For if it's like for example, the 11th number, I will plug in n equals 11. If it's the 20th number, then I will plug in n equals 20. As long as you find a common difference, which is right here, literally the letter D, you can find it, the equation, and plug it in for any number in the future. Pretend just now we find an equals this formula, and then we plug in for finding number 10th number. So I have 25 plus 5 times 10 minus 1, right? And then, well, actually, there's a negative 5. So I have a times negative 5, and then 10 minus 1. This will turn into a 25 minus a 45, which is equals negative 20. And then what if I one day, God forbid, I ask you for what is that 100th number? You can't actually list out every single 100 number. That will be way too long, taking forever. So you'll be using the arithmetic sequence. Once again, there will be a day that we actually spend a whole entire day talking about the arithmetic sequence and geometric sequence. After we finish finding the number negative 5 as our difference, we literally just plug it in. A1 means my first number, and the first number that they give you is a 25. So in here, we plug it in. If they ask you for the 100th number, then you would do 25 plus the negative 5 that you found, and then 100th number, and then they said minus 1, then you have to make sure that you remember to do the minus 1. That will turn into a 25 plus a negative 5 times a 99. 5, 4, 4, 9. Negative 495. That will turn into a negative 470. So that will be your final answer if you actually like keep subtracting 5, subtracting 5, subtracting 5 100 times later to find a, 99 times later to find a 100th number. That will be negative 470. But once again, we're going to spend a whole day on that, so do not panic. But as long as you are looking for something small right now, 10th number, we can do it by hand and write down every single number out there. Okay? All right, number 9. When the formula P equals 2L plus 2W, this is actually something that we have seen a long time ago. And this is also 8th grade standard talking about manipulating and isolating variable. And actually, we did it this morning. So they said that they want to isolate. Oh, look at this. The keyword solve for. Didn't we just see it this morning? We stressed about the word solve for means what? Isolating some variable. So they said that I want to isolate a variable W. So the original formula is P equals to 2L plus 2W. Right, same thing. I keep my eyes in here, fix on the W, and kick out everything else using
Missy,
property.
I'm gonna leave. Sorry, I'm so sorry to interrupt you. I'm gonna leave
Yeah,
at 6, if
okay,
that's
no
okay.
problem. Yeah,
Not now. Okay.
yeah.
It's my bookie butt.
No, no problem. All right, so I keep my eyes on the W, so I'm going to fix it and make sure that that W don't move anywhere. So the only thing that you can kick out is 2L. So what you're going to do with the 2L? Using opposite operation, which is properties of equalities. You have a positive 2L, so what you're going to do now? In the chat, unmute yourself, regardless how it is. If you have a 2L, you already add 2L, so what you got to do? This is a positive 2L plus 2W, but you don't want the 2L, so what you got to do? There we go, subtract it. There we go, subtraction. So I have minus 2L on both sides, minus 2L on both sides. As we mentioned before, this is properties of equalities. So on the left side, I'll have P minus 2L. On the right side, I only have 2W. All right, see, once again, subtraction, property of equality. At the very end right now, what you got to do? You got 2W, but you want 1W, so what you got to do? So this 2 is a 2 times. How would you get rid of a 2? Not subtract though. I have a 2 times. What's the opposite of times? Divide. There we go. So this is going to be division, properties of equality. This is something that we have done this morning, talking about when we solve for and variable. We're going to go ahead and remove everything that is not related with it. So we're going to do all the opposite operation by like peeling the onion like we did a long time ago. So now this time we divide by 2, or you can do a whole entire thing divide by 2. You don't necessarily have to separate them. So the 2 was gone. So now your W will equal P minus 2L together, divide by 2. Or if you want to, you can separate it, divide by 2 separately. It will be P over 2 minus L itself, because the 2 and the 2 can simplify. So that is how we have one answer, which is right here. All right, they have two different representation, but it's the same exact answer. Okay, so we're gonna have answer choice number 2. This is something that we have done this morning, but if you miss it, go back to Google Classroom and check out the notes, okay? Okay. All right, good. Thank you, Chris. Number 10. The Market Street Pizza kept a record of pizza sales in the month of February. The results are shown in the table below. And then we have thin crust, deep dish, and then plain, veggie, meat only, and then the works. Oh, and then of all the pizzas sold in February, what percent were plain deep dish pizzas? So this they want to talk about out of. And here is of means out of. That means that I want this to be a division. The bottom is always going to be out of, and the top is something that they want to count. All right, so let's take a look. They said out of all the pizza. So I need to have a number that I sold for everything. So with all of these numbers, they did not give you what they sold, but it's okay to calculate. So I'm going to put in 300 plus an 80, and then plus the 120 and plus the 100 and all that. Add them all together. This is a sum of every single pizza. And I'm a lazy person that I don't want to do a calculator, so let me go ahead and punch it in the scientific calculator in here. So I have a 300 plus 200 plus 80 plus 25 plus 120 plus 105 plus 100 plus 70. So, oh, there's 1,000 pizza. That's kind of crazy. They sell 1,000 pizzas. Okay, so in here, they sold 1,000 pizza. But what they want though, they want the plain and at the same time, deep dish. So plain goes right here. Deep dish goes right here. So the only number that satisfies is just 200. So on the top, I'm going to go ahead and put what they want, which is exactly at 200. So what percentage is that? 200 out of 1,000. But once again, we have a calculator. So 200 divided by 1,000. All right, I got the number 0.2. What percentage is that? 20%. There we go. And then we circle that and move on, and that was it. So numbers and solvings are not always that hard or that crazy. It's just about like, what is your point of view? Do you know how to find out a hint from words, from the question, and between the lines? All right. So in here, the word of means just out of. When you hear the word out of something, that means you're going to do a division. All right, and then say out of all the pizza. So I don't know what's all the pizza, so I got to do a calculator and find out what's all of them together by addition. And then they said plain and deep dish. So I'm going to go ahead and find whatever the number is in the cross to make sure that I'm satisfying both, just like that. So that's why 200 divided by 1,000. So the number calculation wasn't too crazy, but the thing is we have to understand what's their logic, what are they asking and behind all of these. All right, the next one is a DCSP. But once again, I showed you yesterday on a graphing calculator about how to solve this. But before we move on, I'm going to go ahead and ask you to use DCSP to solve. And I'm going to go ahead and work with you guys since you guys are not turning on your mic. If you want to, that's fine too. But in here, let's go and take a look at DCSP. And then I have this. And then equals that, then that. So according to DCSP, I'm going to go ahead and do a distribution. That's my D. I have a negative 6x and then plus a 10 equals 9 over 2x minus 2. All right, C, nothing. So S, picking on a smaller variable or pick on one variable, doing subtractions, properties of equalities. Or maybe addition properties of equality. Doesn't matter which one. So in here, I see a negative number and a positive number. So I guess I'm going to choose a negative number to get rid of, right? So I do addition for 6x and addition for 6x. So now I have 10 equals, what is 9 over 2 plus 6? Once again, Decimal's graphic calculator comes in very handy. You don't even need to punch in an on button. 9 divided by 2, and then plus a 6. They give you 10.5. All right, so 10.5 of an x minus 2. That's my combined like terms, or actually a properties of equality. When that's done, another property of equality by plus 2 plus 2. So I got 12 equals 10.5x. Okay, final step, division properties of equality, divide and divide. But look at this. If a human being doing this look crazy, but you have a calculator. So 12 divided by 10.5. And then the answer is 1.14285. That's kind of too crazy, but let's go ahead and solve it in a better way. There is a fraction button right here. Click on it. You see, that's why I like a Desmos graphing calculator now. On the left side, there is a fraction button. You can actually convert this between a decimal and a fraction. But after you have that, you have x equals 8/7 just by punching the Desmos graphing calculator, okay? So get used to using it. You can go online and search up the decimals for decimals, and then you'll be like using it before you go on the test so that when you are in the test, you're not panicking about like, oh my God, what are all these features? How do you use it and all of that? But once again, you have the answer. What was a better way of using this calculator without solving it by hand? But once again, whatever's on the screen right now as a note, I will show you about a way that rely on a scientific calculator with no graphing. But you were provided with a graphing calculator. What's the best thing to do? You type in whatever's on the left side of the equation as one line. You type in whatever's on the right side of the equation as another line. Let me show you the magic. So I type in -2 parentheses 3x and then -5. All right, so that's my first one. And then the second one is 9/2 and then x and then -2. All right, I hover over for a prime by the cross. I click on it. They set 1.1428. They give me the answer immediately. And that is the only answer that fits the description, which is the 8/7. All right. So once again, I can draw it using decimal. I got it, the answer just like that immediately. I don't even need to solve anything about DCSP. No writing, no nothing. This is a multiple choice. They don't want to see your answer anyway. They just want to say, oh, do you get the multiple choice correct? So that's how you do it. You plug it in and they show you everything and you choose the answer. Because in here, I got my answer is 1.14286. And then out of all of that, this is the only answer that is about to be 1, more than 1, and then a positive number. So that's why you choose that. If you're not confident, punch in here, type in 8/7. Oh, is that 1.14? Great. Type in 10/11. Is that 1.14? No. You type in the rest of the two negative numbers and you'll see. But once again, smartly use the decimals graphing calculator is one of the features that will help you to get higher points. Even though you don't know or you don't remember how to do DCSP at the moment and be like, oh my God, my brain froze. I don't remember what to do. But Ms. He said that you can use decimals graphing calculator. So use that. Everybody cool? I hope you're okay. Okay. All right, no objection. I guess you're okay. Number 12. This is a exponent rule that we have talked about. Literally, there are still posters in my classroom. So this is just combining stuff. We're going to go ahead. The best choice is always going to be analyzing from the answer reversely to the question, and we'll see which one works. First thing, exponents are not mergeable when you're doing addition. So these two will be gone immediately. Answer 1 and 2 will not be my choice because you cannot add two bases together and then to merge into one answer. That's a no-no. No is a no. Only by multiplication. So what will happen in here? Same base multiplication. That means you keep the base and you add up all of the exponents. So that will be a plus b. And another way, a plus a will be 2a. So x 2a plus b. Solve the other one. Same base, keep the base, and then you add up the exponents. So I have x, a plus b plus a plus b. That will turn into 2a plus 2b. Okay, so which one match the answer? Only answer choice number 3. Just like that. Okay, so this is going to be better for you to review about all the exponent rules. And if you don't remember, go back to your classroom and look at all the posters that Miss Perez made, or look at your notes. These are all the exponent rules, okay? Same base multiplication can only add up the exponent. Same base division, you can only subtract the exponent, okay? Okay. So next one, let's take a look question number 13 in 2 different point of view. I'm going to screenshot. Okay, you're going to screenshot. Go ahead and screenshot. But once again, all of these will be in Google Classroom. I will export the whole entire PDF and put it in Google Classroom. All right. All right, question number 13. You got two different methods to solve it. You can either use the Desmos graphing calculator to punch in all of them, or you analyze it on paper. I'm going to show you the analyzing on paper first, because once again, Desmos is always, I want to treat it as my last resort to help you. If you panic, what do you do? But if you don't, if you remember all the procedures, I will encourage you to solve everything on paper. So let's take a look. What's the relationship between these two? Because the 0.06 is too small. I don't want to analyze that. Well, that was a double, so that's a times 2. What is a quarter and 50 cents? Once again, that's a double. What about 50 cents and a dollar? That's a double. What about $1 and $2? That's a double. If I'm multiplying a number over and over and over and over again, I'm actually doing exponential. So this will be an exponential growth. Now, last week on the Friday, I actually make a chart talking about the sequence and the functions relationship.
Missy, sorry. I'm logging off.
Yeah,
Bye, my girl. Bye, guys.
and bye, Margaret. Okay, so what is the difference between all of that? So arithmetic sequence will be you adding some number over and over and again, or subtracting a number over and over again. But in reality, when you write out as an equation, there will be a linear equation. They will have a y equals mx plus b. That means you will have a linear equation. And then the geometric sequence will be multiplying some ratio. So at the end, you actually will have an exponential function. So you have a y equals some base, which is, well, actually your base is your ratio. All right, some ratio, and then to some exponent, to some power. So you're gonna, multiply the r 1 time, multiply the r 2 times, multiply the r 3 times. You're multiplying the number over and over and over again. So that's how they look like. And then here, realize that this is a multiply by 2. Multiply by 2 only fits the description of multiplying a number over and over and over and over again. So that's going to be a geometric sequence, aka an exponential function. So once again, this is called a multiplying over and over and over again. This one is adding and over and over and over again. Okay, so that's how these things are related to each other. All right, but how do you do it on a Desmos graphing calculator? You have a chart. You can make a chart and then you can literally type in everything that they give you. This one 0.0625 and then 0.125. And then you have 1, 2, 3, 4, 5. You type it in 0.25, 0.5, and then 1 and 2. So this will show up in here, but there's a magic in here. On the upper left corner, there is called regression. You click on it, and then is a linear regression? No, they don't actually fit everything. Is it quadratic regression? No, they don't technically fit everything. Is it an exponential regression? Actually, look at this. This is beautifully fitting everything in here. All right, look at that. So I'm going to do it one more time. Linear regression? No. And then quadratic regression? No. Not everything is on the point. And then exponential regression? Look at this. Beautifully fitting every single spot. That is how you know that is a exponential. But once again, this is your last resort about how to use Desmos to help you analyze the answer. But if you can do it by hand, I always encourage you to do it by hand. All right. Hope you're good. All right, bye. You can catch up the rest on the video tonight, okay? Thank you for joining. All right. Number 14. They said solving the equation, and the first step is this. This is something that we analyzed before and we have checked like 4 million times already. What is missing? What was gone? And what is your answer? Let's analyze. The x is still there, and then 7x is still there. That means they haven't been touched. The only thing that was gone, that was missing, was a negative a. So what did that guy do? Repeat that. Okay, so we're analyzing what kind of properties was used. It can be commutative property, distribution property, and then any of the properties of equality, addition, subtraction, multiplication, division, all of them are called properties of equality. And then we have a associative property. All of these properties were being used, but we analyze what actually do happen in their answer. Now we know what to do. We always like combining like terms and distribution, all of that. That's our order of solving. But other people might do it differently. In this question, Stephanie right here is actually, oh, I did not touch anything about the x squared. I did not touch anything about the 7x. They're still at the same exact location. The only thing that was missing is a negative a. How would you delete a negative a? I've seen that a couple questions ago. How would you delete something? How would you delete something? Number 3, distributive property. We wish, but the thing is like distributive property, we need a parentheses. We don't have a parentheses, so we can't do distributive property. We need a parentheses in here. So distributive properties, no. How can we get rid of a minus a? Lily, what about you? How would you get rid of a minus a? What do you think, Chris? What's the opposite of a negative a? Plus 8. There we go. So in here, plus 8 and plus 8. And let's double check. Negative 12 plus a. There we go. Addition properties of equality. So right there. If I plus 8 on both sides, then negative a and the positive a will go away. Right? And then negative 12 plus an 8 will become a negative 4. So that's why addition property of equality. Yes, that's 4. All right. So that's how we actually do analyze out what's happening in other people's answer instead of actually solving them. So these are called the features. Yeah, yeah, we're going to do that. Question number 15. Let's take a look. This is combine like terms. So what we're going to do, they said the sum. Sum means addition. So now this is an 8 square root of 3 add on with the square root of 3. What do we have as an answer? This is just combine like terms. Since we're doing addition, nothing else too crazy. And not answer choice 1. So just like that means that we are combining like terms. Square root of 3 are just like their terms. So I have 8 of that plus 1 of that. So together I have 9 of that. Oh, what's that? That is square root of 3, and that is going to be answer choice not 2. Look at it. Look at it. Where's the answer? 4. Yes, Chris, that's 4. All right. So what is happening in here? Square root is just like your letter X and Y's. So you can't change whatever's inside the letter X. You can't change that, for example. Oh, X plus another X. You can't change the letter X. It won't be turned into a Y. So whatever's underneath the square root, you can't touch it. So you can only change whatever's on the outside. That means you're combining like terms. Imagine this into 8 stars plus 1 star. Together you got 9 star. And whatever's inside a star, you can change it. So if you start with square root 3, then you end with square root 3. And you can only add up with the coefficient, so you can't touch anything that's inside the square root. Good? Okay, so that's why we're choosing 9 square root 3. Yeah, good job. So when you see it in the test next time, then you won't be forgetting this. So these are just replacing what, like, it was like, oh, 8 roadblocks plus 1 roadblocks, or 8 switch plus 1 switch together is 9 switch. And you can say that whatever 8 PS5 plus 1 PS5 together is 9 PS5, things like that. Okay. So those are the words that you replace with the things that you see in daily life so that you don't change whatever is inside the word. Okay. Okay. All right. Oh, next one. Let's take a look. The dot plots. We're going to spend the last Monday before the regions on dot plot and box whisker. And let's take a look what happened here. They said that for 20 students in the math test, And then the mode of this math test is 80 and the median is 85, which dot plots correctly represent data. Okay, so this is actually a key point talking about was a mode, was median. Now we explain it, sorry, I explained it to Margot last Friday in the video. Mode means whatever show up the most. Whatever is had the maximum amount was the most amount of data. And median have it containing the letter D is the middle. So when you finish canceling out a highest one and a lowest one, when you find out the middle, that's called a median. Let's take a look. First one, mode. In this box, what is the maximum? What is the most dot that you see on where, which number? What do you mean one? Oh, we're analyzing in this picture only. What is the highest amount of number that you see? 80, there we go. So in this, I will have a mode of 80. All right, and picture number 2. What's the mode in here? What's the mode? What's the number that contains the most spot? 85. Okay, perfect. That's the mode of 85. All right, and the third picture, what is the mode? $80, perfect. Right here, 80 is the mode. Once again, mode is like the highest column, whatever is containing the most amount of dot. Most of dot. All right. And then save the answer for Chris. Chris, what is the mode in the fourth picture? $85, perfect. So in here, I got an 85 mode. So what's the question one? The question one that they want a mode as of 80. So that means this is going to be gone. This is going to be gone. And then the only thing that fits the description is 1 and 3. Let's take a look at the next one. They said a median of 85. That means I got to find the middle number. Once again, whatever contains the letter D, middle, median. So I'm going to go cancel high, low, and then we're going to cancel that until we find 85. All right, lowest, highest. And then delete lowest, and then highest. Lowest, highest. Lowest, highest, lowest, highest, lowest, highest, lowest, highest, lowest, highest, lowest, highest. So in here, my middle is an 85. So this is a median, 85. All right, number 1 do actually fits my description. Let's take a look at number 3. How is that it or how is it not? Lowest, highest. Lowest, highest, lowest, highest, lowest, highest, lowest, highest, lowest, highest, lowest, highest. Whatever it is in here, that's my median. So I got a median of 80. So that's why this is not my answer because I want my median of 85. Chris, doing okay? You can unmute yourself and ask me questions. Okay, good. So that's how we know that the median needs to fit the description or maybe not. Same another practice. Let me just do one other one for number 4. Once again, low, high, low and high, and low and high. Low and high, and low and high, and low and high. Low and high, low and high, low and high. I got the last 2 being in the middle, so I'm going to find the average between the middle and here. So my median will be at 82.5. Okay, so that is how you know that 4 will not be an answer. Okay, we keep deleting highest, lowest, high, lowest, highest, lowest until we find whatever's remaining in the center. That's called median. Okay, okay, good. Let's take a look at the next one. Function is graph on the axis below, the domain of the function. All right, so that means what can be done by using as x? And we know the domain is sweeping vertically from your left to your right. So what's the left answer? Oh, right here, which is the -2. So anything containing -4 will be gone. So this is my -2 in here. Do I include or not include? This is a hollow spot. Do I include or not include? Include or not include? I'm not gonna include because this is hollow. So this is one of the key points. Hollow is not include.
Missy, can you hear me?
Yes, I do.
Okay, I changed my thing because yeah, because it wasn't working. So
Yep.
yeah, it's working now.
Yes. Now you can unmute yourself.
Yeah, I can unmute myself.
Yes. All right. So my domain is I'm gonna have a hollow at -2. So that means I'm not include. So do I have an equal sign?
No.
So the answer choice is?
Two.
You just told me that no equal sign.
Oh yeah, no. Okay, sign. So uh, wait, what?
Which one contains no equal sign?
Wait, no, I accidentally zoomed
Don't
in. Wait,
worry.
hold up.
I'll do that, but which one contain no equal sign?
I zoomed in by accident. I can't see the question. Oh, okay, I can see it again. The one that contains no equal sign is the first one.
There we go. That's how we choose the first one as an answer. Okay.
So when it's hollow,
It's not include, so no equal sign.
okay, let me take that note. So hollow. Okay.
And this one is a yes equal sign.
Okay. Okay, I
Is that
got
your
it.
sister?
Yeah, that's my sister.
Tell her to get ready for algebra region. All right, next one. Which one order pair is on the solution? And you know what's my favorite thing to do, actually. You can either plug them all in. That's how you solve it by hand. So that's like you check
Yeah.
the answer as today's, right? You check by plugging in.
Yeah.
But you know, I am a lazy person that who loves to use tools so much. So I'll type it in. Y minus 1
Yeah.
equals, and then 2 parentheses x plus 1/4. Oh, hi, Charlotte. Hi, baby.
Charlotte.
Hi, Charlotte. Yeah. Hi, Charlotte. Look, that's Charlotte.
Hi.
Baby, say hi, hi. Hi. Baby, hi. Say, she give you a kiss. Baby, Fame. Come on, Fame. Baby, come here.
Yay.
你睇佢啊，我未落課。Baby say bye bye. Bye bye. Bye bye. 講 bye bye. Bye.
Hi.
Alright, she's gonna wash her hands. She's gonna come back later. Baby
Okay.
say something. Go. Say something. Go. All right, so we're gonna finish this question by plugging it in. So they have a couple points. I'm gonna go check if 0.75, 0 is an answer. Okay, right there. Do you think that's an answer? The purple one right there?
No.
No, it's not even on the green. So I'm gonna test on the next one. 1.25 comma 4 with a parentheses. Is that on it?
It's on it.
Yay, so we're gonna have an answer. But just in case, double check everybody else, right?
Yeah.
So I'm gonna have 2.5 comma -6.5. All right, what do you think?
No. It's all the
No,
way there.
exactly, it's all the way down. And the last one, I have a 4 comma -9.5. I don't
I
even
don't
know.
even see it. Oh, it's all the way there. It's right there.
There. It's all the way down in blue. So not on it. So we can test it by that. Or if you want to check it by hand, that's fine too, by plugging in all of that. Okay.
Yeah.
Okay. All right. 19. This show up in every single test is always about canceling the units. So they said, let's take a look. The fast time for the 50-meter dash is 7 seconds. And then she want to know how fast in inches per minute. So that means in the final answer, I want to keep that. I want inches per minute as an answer. So how would I cancel that? Every single time when you're able to cancel some units is always a top and bottom and top and bottom. Okay. So
Yeah.
let's take a look.
Missy, I could do one more question, but then I gotta go.
Okay, that's fine. It's totally fine. Say hi, baby. Hi. Do you see Charlotte?
Hi, Charlotte.
Hey, baby. Hi.
Hi,
Hi.
Charlotte. Hold on, let me tell my
Hi.
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 She just walked in your room.
She just roamed in my room. She came back from a park.
Oh, hi, Charlotte.
Hi, baby, hi. Oh, ding. Oh, she's trying to put the finger and then help you. Ding. All right. So let's finish this question.
Okay.
So seconds and seconds in the same exact row, they will never be canceled. So you can never put the same exact unit on the same layer. You can only be one top, one bottom, one top, one bottom. So
It
that's
has to be different?
yes, it have to be one top, one bottom. Have
Okay.
to be in different location. That's how
Okay.
we cancel out units that we don't want. Let's take a
Okay.
look. Seconds and seconds are gone. Good, because they're in the opposite place, right? And then
Yeah.
let's take a look. But meter and meter end up in the same layer. Do you want them? No, that's not good. Meter and meter cannot be in the same layer. They have to be in one top, one bottom, right? Let's take a look at the next one. Seconds and seconds, they do cancel out. That's great. And then, but once again, meter and meter end up in the same place. We can't let that happen, so that won't be good. And then let's take another one. Second and second cancel out, one top, one bottom. That's great. And then we look at the other one. Meters and meters, one top, one bottom. So the final answer is number
4.
But what if two answer choices have one on top and one on bottom?
there's only one answer. We'll have one top, one bottom.
Oh, okay.
Only one. So that's how we choose this answer. All right.
Okay.
The last week's model is the same thing, but last week they have like 4 things to cancel out. But once again, always only one of them will have never have anything line up in the same place. They will always
Okay.
be one top, one bottom, one top, one bottom. That's the only one that will be the correct answer. Okay.
Okay.
Okay, that makes sense.
I could do one more question because that one was easy. And I can actually do that, but okay. So let's take a look. We're analyzing these number by ordering them in specific locations. So let's start with the smallest number. I see the smallest number is 77. So I write down 77, comma. Next number I see should be 78. And let's see. And then the next number will be 81. And then after that, maybe 84. After that, 86. After that, 88. And then a 93 and a 95. Now I finished order them. Now interquartiles and quartiles, all of these are talking about 25%. That means you just keep chopping everything in half. So I got 4 numbers in here and 4 numbers in here. So that means my median will be right down the middle as a number that between 84 and 86. That's easy. So that's going to be 85, right? There's only one number between 84 and 86. So that's called a median. This is called my maximum number. Sorry, my minimum number. And 95 will become?
Maximum.
There we go. So that's my minimum number. And this is my maximum number. All right. And then they said they want interquartile range. Interquartile range will be a number that you chop it in half again. So what's the middle number between 78 and 81? All right, bye, Chris. Bye-bye. She's just laughing. All right, so the number between 78 and 81, you can say 79.1. Oh, sorry, 79.5. And then the number between 88 and 93, you got, once again, you're going to chop it in half again. So every single time you just keep chopping in half. So this is going to be, let's see, 2.5, so 90.5. So this is going to be my quartile number 1, quartile number 2, quartile number 3, and quartile number 4. So what does this whole entire box whisker do is literally you chop everything into 2 pieces. And then you chop it into 2 pieces again. So that's how you have a 25% of population. How would it be? This is 25% of population. This is another 25% of population. And this is another 25% of population. That's what they want. Okay, always these are the populations that you have. Okay, So that is
Yeah.
how the box whisker is going to be drawn. And then you'll have a box whisker looking like that right now. And the number layers is 77, and then 79.5, and then 85, and then it's 90.5, and then a 95. So this is how you have your number formulated. They said the
Oh.
interquartile range will be simple, which is the middle two boxes. So what's the difference between 79.5 all the way to 90.5? Then you have an 11.
Wait. How'd you get that?
90 minus 79.
What? Oh, so to get the n quarter range, we have to do.
Interquartile range means take a subtraction between the maximum and minimum of the middle two boxes.
So,
Uh,
the the quarter one and
yeah.
quarter three.
Yes.
Okay. Okay.
So
So,
if you don't remember, let me go down all the way to the reference sheet right here. Interquartile range means Q3 minus Q1. You see it now?
oh yeah.
There we go. Just like that. Okay?
Yeah.
All right. And we got a couple questions we can finish. This says right here a function that a x squared is multiplied by k, which k is -1. Which one will be the good representation? So I have a number that is smaller than -1. That means I will have pretend -2. So now I have a -2x squared. How would it look like? Negative. This is something called a transformation that I haven't teach, but you will see that in the future. Transformation. All right. Transformation means that any number that you multiply will be making it look wider, taller, bigger. So any number that's bigger than 1 will make it look bigger. Any negative number will flip it upside down. What are you speaking about, Goody? So flip it upside down. All right. So a regular x squared, let me go ahead and show you. This is the magic about Desmos graphing calculator. Originally, I have an x squared. Okay, x squared.
Okay.
And then now I have a -2x and then square, right? So I will have a fatter or a narrower picture. What would I have?
Smaller.
Smaller, narrower picture. And then did it go up or did it go down?
It went down.
So the answer is
4.
there we go. That's how you choose it.
We're gonna use Desmo graphing calculator for this, so
You,
it'll be easy.
yeah.
Okay.
Yeah. If not, then you have to understand that you are flipping upside down and make it a narrower. So you
Oh,
still choose number 4. But then
okay.
if you don't remember, use the Desmos graphing calculator. Okay.
Okay.
Good.
Okay.
All right. This one, I'm going to show you this. If you want to solve it by hand, wonderful. But I'm not. I'm going to grab this and type it in -4x and then greater than equal to -2.8. So what is the answer?
Uh, parentheses 2.3 comma 0.
So that is my cross point. But what did happening in here? This is literally shade everything on the left side of the 2.3 with a solid dot that they give you. So which one's the answer in here?
What's it called? Is it 3? No. It's 4 because it
Or
has a dot.
yes,
Has
they
a
shade
shaded
everything on
dot.
the left and a solid dot. So that's how Desmo's literally giving you the answer of multiple choice, okay?
It's like a cheating thingy.
Yes.
Like a
But they give
skip.
it to you anyway, so
That's good.
yeah. But it's always about, do you know how to use a tool? Just like iPhone. iPhone was designed and then people need to know how to use it, right?
Yeah.
So some people just use it to calling people, but like they haven't actually discovered how to use a phone. Just like all these, they give you the tool, you need to know how to use it. Okay?
Okay.
Okay. Let's take a look. Next one. We have time to finish the multiple choice. There's only 2 more left. The number of fish in a pond is 8 more than the number of frogs, and the total number of fish and frogs in a pond is at least 20. If X represents the amount of frogs, which inequality can be used to represent the situation? How would you write it?
Um. Uh. Uh. Uh.
Let's take a look. The fish is 8 more than the frog. So let's write it down. Fish is 8 more than the
Frog.
frog, right? So I'm gonna write down the whole word because they both start with F. So fish is equal to frog plus A. Agree?
Yeah.
Is that the total number of fish and frog together? So that means I'm going to have a fish plus a frog that equals to what? At, at least
20. At
At
least 20.
least 20.
At
So that
least
means more than or less than?
more.
So more than equal to 20. We know fish is frog plus A. So in here, I'm going to have a frog plus A and then plus A, frog greater than equal to 20. Didn't we do it today? Today's substitution, remember?
Yeah.
So fish is being replaced by this in a parentheses. All right. So we're replacing that. When that's done, they said that, oh, now frog is going to be the letter X. So I have an X plus A plus X greater than equals to 20. So which one's your answer? Repeat.
Wait. Let me, okay, is
Like
it 2?
Number
Yeah.
2. Combine
Yeah.
like terms, 2x only. There we go. 2x plus an A greater than equals to 20. Just like that. All right. Next one. Interval decreasing. From x -3 to +3, I need a decreasing number. So from this to this place. Is that decreasing in this picture?
No.
No, this is increasing, right?
Yes.
From -3 to +3. Is it increasing or decreasing?
Increasing.
Increasing. From -3 to +3, which is here. Is it increasing or decreasing?
Like going up and down?
Perfect. I have an increasing and then a decreasing, right?
Yeah.
From -3 to 3. What is this?
Decreasing.
Decreasing. So the only answer choice is?
4.
There we go. All
What
right.
does interval mean? Like,
Interval
decrease.
means from somewhere to somewhere.
Okay, decreasing. Okay, never mind. I didn't see the decreasing.
Yeah. All
Yeah.
right. So that was it.
Oh, yeah. Yay.
Yay. All right. So I'm going to go ahead and pause and I'm going to see you Tuesday. All right.
Okay.
BB, say bye-bye. Bye.
Bye.
BB, say bye-bye. Bye,
Bye.
Charlie. Oh, look at her. Bye-bye. Baby, say bye-bye. Baby, go on bye-bye. Say bye-bye. Bye-bye.
Bye.
Oh, okay. She want to
Bye.
go. Bye. I'll see you Tuesday.
Bye, Missy. Thank you.
No problem. Ooh, she said bye-bye.
Yay.